All right, so this is lesson 6.3, proving that a quadrilateral is a parallelogram. Our first theorem, theorem 6.9, states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, if you would have something like side AB congruent to side DC, and also segment AD congruent to BC, then you can say that ABCD is a parallelogram. Let's look at the next theorem. Theorem 6.10 says if both pairs of opposite angles are congruent to each other, angle A is congruent to angle C, and angle B is congruent to angle D, then the quadrilateral is a parallelogram. Theorem 6.11 says that if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So I have diagonal AC and diagonal BD. I only know that they bisect each other if the segments are congruent to each other where they've been bisected. So I need to add an ordered pair, or add a point there. Let's call that point F. So I have AF congruent to CF. I'm also going to show that DF is congruent to BF. So if I have that scenario, I can state that the quadrilateral is a parallelogram. And lastly, if one pair of opposite sides, so let's say that segment AB is congruent to segment DC, if one pair of opposite sides are both congruent and parallel, AB is also parallel to CD, then the quadrilateral is a parallelogram. All right. Let's look at our first example. We need to find the values of x and y for quadrilateral ABCD, and it must be a parallelogram. Well, we know that if it's a parallelogram, then 8x plus 12 must be equal to 10x minus 24, because remember the diagonals bisect each other. So 2x equals 36, 18 equals x. We also know that the same is true for the other side, the other diagonal. So 2y minus 80 must be equal to y plus 9. So y equals 89. Let's look at example number 2. Example number 2 asks us to determine whether the quadrilateral is a parallelogram, and we have to explain. So let's look at example 2A. The first thing that we need to see is that I have opposite sides, one pair of opposite sides congruent to each other, but I do not have another pair of opposite sides. It doesn't say that those are congruent. All right. We also see that the diagonal is dividing it into two triangles. Are they congruent triangles? Could we prove that the triangles were congruent based off of what we know? So let's try that. Let's see if we can prove that the triangles are congruent. So I have a triangle with side 8, 8, and 7. Well, this triangle also has a side of 8 and 7, but we don't know this side. So we do not have enough information. So we cannot prove. All right, let's look at the second example, example 2B. Do we have enough information to prove that this must be a parallelogram? Well, we can do a couple of things. First of all, we know from our previous lesson the interior angle sum, the sum of the interior angles, must be the number of sides, 1, 2, 3, 4, minus 2 times 180. So n minus 2 is 2 times 180 equals 360. So we can go about this two ways. The first thing that we can do is use what we know about interior angles and just say, if we were to call this side x, we could say that 360 equals 105 plus 75 plus x plus 75. Then I have 360 equals 255 plus x. I would subtract 255 from both sides and find out that 105 equals x. So I could use the interior angles theorem. And by using that, I find out that this has a measure of 105 degrees. And because the opposite angles are congruent to each other, then I can say that yes, this is a parallelogram. All right, our last example asks us to determine whether or not the quadrilateral is a parallelogram given the ordered pairs. So when we look at this, I'm going to just do a sketch of a parallelogram. A, B, C, and D. Well, we're trying to determine whether it's a parallelogram. Well, one of the things that we know is that if it's a parallelogram, we can do this a couple of ways. First of all, we can use slope. We could use slope and say that, prove that AB is parallel to CD. We could also prove that segment AD was parallel to BC. So that's one method, using slope. The other method we could use, your most favorite probably, is using the distance formula. We could show that AB equals CD, the distance from A to B is equal to the distance from C to D, and that the distance from A to D equals the distance from B to C. So this is using the distance formula. We can also use the midpoint formula, because if it is a parallelogram, we know that the diagonals bisect each other, meaning that they are going to intersect at one another's midpoints. So I could also use the midpoint formula, which actually is my most favorite just because I think it's the easiest. I don't know. So I am going to prove that the diagonals bisect each other, because if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. That's theorem 611. So let's find the midpoint of these diagonals. So I'm going to erase my work over here, and I'm going to find the midpoint. Remember, in order to find the midpoint, we just add x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So here we go. The midpoint of AC, because that's my diagonal there, the midpoint of AC is, well, point A, the x-coordinate is 2 plus 7 divided by 2, and the y-coordinate 3 minus 2 over 2. So the midpoint takes place at 9/2, 1/2. That's the ordered pair, 9/2, 1/2. So if this is in fact a parallelogram, the diagonal DB will also intersect, its midpoint will also be at 9/2, 1/2. So let's check that. So the midpoint of BD, let's see, what are those points? So B is the x-coordinate. X is 8 plus 1 over 2. That's looking good. And 4 minus 3 over 2. That's also looking really good. So let's see, the midpoint of BD actually takes place at the ordered pair 9/2, 1/2, which just happens to be the same. So this is, in fact, a parallelogram. So again, remember, there are a couple ways that you could do that. You could use slope and prove that the opposite sides are parallel. You could use the distance formula to prove that the opposite sides are congruent to one another, or you could use the midpoint formula and prove that the diagonals intersect one another at the same point, which is the bisection point, because that's what midpoint is. The last thing that you could do is prove that one pair of sides was congruent to one another or parallel, but again, that's a lot of work. So your choice, use whichever method you like the best.